everyone. Myself, Dr. Ambika. I'm an entrepreneur, algal entrepreneur. I'm from Germany. Today, I'm going to talk about role of nannochloropsis in biofuel production. So the topics we'll be covering in this presentation are as follows. What are algae fuel and a little bit of history behind that algae fuel, and the definition and the brief classification of algae, and what could be the cultural techniques and systems we use for microalgae cultivation, and what are the factors limiting for microalgal growth. And as I have chosen the topic about nannochloropsis, which is involved in the production of biofuel. So let me take you a brief introduction about this species and what could be the potential of algae oil or fuel as a source, and what could be the advantages and disadvantages of this biodiesel from algae oil, and what are the challenges we have to face while getting into this biodiesel or biofuel from this algae. So finally, I'll be concluding with the remarks and future perspectives. So, what is algae fuel? Algae fuel or algal biofuel is an alternative to liquid fossil fuels that uses algae as its source of energy rich oils. Also, this is an alternative to commonly known biofuel sources such as corn and sugarcane. So, previous speakers have spoke about this sugarcane bagasse. Just like that, this is also a common known biofuel source you can consider as. So let's talk about a little bit history behind this, how it has been initiated, how the people have got an constant interest on this microalgae with related to this biofuel production. So initially in 1942, Harder and Witch were the first two persons to propose this microalgae be grown as a source of lipids for food and fuel. So after the World War II, research began in US, Germany, Japan, England, and Israel. They started culturing these techniques and they started building a engineering system for growing this microalgae large scale, particularly for the genus Chlorella. So in that time, they were not knew about so many species. They were only concentrating on this Chlorella pyrenoidosa, and why they have concentrated on this, because they could be induced via nitrogen starvation to accumulate as much as 70% of dry weight of as lipids. So that means it would be a benefit for biofuel production. Since the need for alternative transportation fuel has subsided after World War, research at this time focused on culturing algae as a food source or in some cases for wastewater treatment. So, interest in this application of algae for biofuels recommended or kindly during the algae embroidery, the algae price surge of 1970s leads this Department of Energy to concentrate more on this microalgal work. So, on the contribution of this algal biofuel research, have indirectly from the project focusing on different application of algal culture. For example, in 1919, Japan's research institution initiative technology implemented research program with the goal of developing systems which fix the carbon dioxide using microalgae. So we'll come to know why how this microalgae fixes this carbon dioxide in further slides. So although they have a goal of not was not energy production, and several studies have demonstrated these algae could be grown using fuel gas from power plants as a carbon dioxide source, an important development for algal biofuel research. So other work focusing on harvesting hydrogen gas, methane, ethanol from algae, as well as the nutritional supplements and pharmaceutical compounds, has also helped to form research on biofuel production from algae. So this is a quite introduction, history behind how it has been initiated in 1970s. So I would like to give a brief idea what is algae. So algae is nothing but an aquatic photosynthetic organism simply. So these covers a number of different phylogenetic group, approximately at 30,000 species. In general, they can be categorized as multicellular macroalgae. You can see the macroalgae on the right side, that Colepra racemosa is a microalgae, and unicellular microalgae, that is microscopic. You can see through microscopic. So that is Chlorella vulgaris. You can see in the left picture. So how it fixes the carbon dioxide as a photosynthesis, as plants does. So these will also undergo photosynthesis in the process by which light energy will be converted into chemical energy, whereby carbon dioxide and water are converted into organic molecules. So these chemical energy is stored in the form of chemical compounds with particular biological activities named as bioactive compounds. This is how algae also fixes the environmental carbon dioxide, just like plants. So, brief classification. So, algae has been classified into microalgae and macroalgae. Microalgae has four phylums: Cyanophyta, Pyrophyta, Chrysophyta, and Chlorophyta. Cyanophyta is nothing but blue-green algae. Pyrophyta is dinoflagellates. Chrysophyta is diatoms, and Chlorophyta is another green algae. And macroalgae is nothing but seaweeds, so which has three phylums: Chlorophyta, green algae, Rhodophyta, red algae, and Phaeophyta, brown algae. So, what could be the cultural techniques for microalgae? So, microalgae has several techniques available for the cultivation, but the thing is, the choice of technique is mainly based on the selected microalgal strains as well as its application. Which species you would like to grow, that is, it's a main factor which depends on which method you can follow, because few species require open type of culture system is okay with the few species, and for particular species of algae we have to go for closed cultural system, that is by means of photobioreactors, because few species are very sensitive to the contamination. So that cases you have to go for photobioreactor type of, I mean to say, closed culture system, so that to avoid a contamination. But few other species will be okay with the, not so sensitive with the contamination, they can barely okay with the open culture system. So this type of technique you will choose. It's completely depend on the microalgal strain which you are going to select. So as per the diagram, you can say algal culture techniques has two cultures: one is closed culture system, another one is open culture system. So open culture system, which is cheaper and less control prone to the contamination, and when come to the closed culture system, it is quite expensive, and you can expect very less contamination, and you can say a controlled less contamination you can expect from this closed culture system. So again, when you go for open culture, you will say a batch mode culture is there, continuous mode culture is there, and semi-continuous is there. Continuous mode is high efficiency. The production will be very high, but it is very difficult to maintain and less reliable. When it is come to batch mode, it is more reliable and easiest to maintain. So semi-continuous is easiest to maintain, and it is less reliable, somewhat a consistent, you can say. So cultivation system for microalgae, as I told, open cultivation, you can see this open cultivation is two circular pond type cultivation, you can go for it, and raceway pond. Here in these two open cultivation, you cannot expect a fully controlled contamination, or you need to monitor so much, because the light and the temperature, the environment, the balance of pH, everything should be maintained by you, and it is quite risky because of contamination, but it is cheaper method to cultivate any species. And next is a closed photobioreactor, closed type system of microalgae cultivation, that is photobioreactor. This is a quite expensive and a less contamination, controlled contamination. You can monitor all the pH, the temperature, the nutrients level, the carbon dioxide influence, everything you can be controlled under one system, that is photobioreactor. So these are two methods of cultivation you could see in the cultivation of microalgae. And what are the main factors which is limiting the microalgal growth? A number of cultivation parameters such as light, intensity, photoperiod, temperature, salinity, pH, mixing, etc., influence the growth of microalgae. Thus, it becomes imperative to optimize and maintain these parameters during the cultivation period. The parameters range is so optimal 18 to 24, and salinity gram per liter should be 20 to 24, and light intensity 1000 to 10,000 to 2005 to 5000 optimum. Photo period light is 16 by 8, 24 by 0. pH is 7 to 9. So these are all but this is an optimum or general factors, limiting factors for microalgal growth. But when you select a particular species of organisms, so definitely it varies. So um, few species require a more temperature, few species require less salinity, few species require high light intensity, less intensity. Photo period will be very dark, will be high, light will be low, pH will be high, low. It's completely depend on the species selection. Come to the Nannochloropsis species. What are these Nannochloropsis species? Nannochloropsis is a genus of algae and which comprising six known species, namely Nannochloropsis australis, Nannochloropsis gaditana, Nannochloropsis granulata, Nannochloropsis liminetica, Nannochloropsis oceanitica, and Nannochloropsis oculata, and Nannochloropsis salina. These six species which comes under this Nannochloropsis algae, and these have mostly been marine environment, but also they can occur in fresh and brackish water. That means you can grow them in marine environment, fresh environment, and in brackish water also you can. So these species are very flexible in their origin. So all of the species are small non-motile spheres. So the algae of the genus Nannochloropsis is differ from other related microalgae in that they have chlorophyll A, but these Nannochloropsis is a lack of chlorophyll B and C. Chlorophyll B and C is completely absent in Nannochloropsis, but it has only a chlorophyll A when compared to other related microalgae. Usually, microalgae will be having chlorophyll A, B, C, everything, but this microalgae will be having only a chlorophyll A. In addition, they are able to build up a high concentration range of pigments such as astaxanthin, zeaxanthin, and cataxanthin. So these are the pigments when microalgae undergoes stressed environment. For example, as I told, so each species has its own limiting growth factors like temperature, light period, light intensity, pH, everything. When it is varies, you cannot manage, when you cannot manage to hold their limiting factor, then definitely they'll undergo stress condition. So in that stress condition, these generally I'm talking about these microalgae will go for pigment production to protect themselves from these adverse environmental conditions. So then these pigments will be produced, but these pigments are very beneficial so to the human being in health, in health a field, definitely. So such pigments are astaxanthin, zeaxanthin, and canthaxanthin. So commonly this astaxanthin will be present in more in Hematococcus pulvalis. So but this Nannochloropsis also having the high concentration range of these pigments, astaxanthin, zeaxanthin, and canthaxanthin, only when produced when undergo very stressed environmental conditions. So this is how the microscopic view of this is a species Nannochloropsis oculata. So they have the diameter about 2 to 3 micrometer and very simple ultrastructure with a reduced structural element compared to the other taxa. So this why I've taken this Nannochloropsis for this biofuel production. You will come to know in next few slides. But this Nannochloropsis is considered as a promising algae for industrial application because its ability to accumulate high level of polyunsaturated fatty acids around 32 for 27 to 35% of dry weight of its own. You can get the polyunsaturated fatty acids. So that is the reason we can consider Nannochloropsis is one of the promising algae in the industrial applications. So, what is algae? Why we are, rather we are having so many sources of plant sources? Why we have to behind this algae for the fuel sources? What could be the potential of this algae oil as a fuel source? Over 80% of energy we use come from the fossil fuels, for example petroleum, coal and natural gas. About 98% of carbon emission result from fossil fuel combustion. We all know that. So, to reducing the use of fossil fuel would significantly reduce the amount of carbon dioxide and other pollutant produced. So, this can be achieved only either by using less energy altogether or by replacing these fossil fuel by renewable fuels like these algae fuels or other biofuels. By other biofuels from the plant sources also you can use or replaced by these fossil fuels uh, to control the pollution and just to reduce the amount of carbon dioxide in the environment. This renewable energy is a promising alternative solution because we all know that it fixes the carbon dioxide in the atmosphere through photosynthesis, just like plants. This algae also does the same process. So they have produced lower or negligible levels of greenhouses gases and other pollutant when compared with the fossil energy source they replace. Algae like corn, soya beans, sugarcane, wood, and other plants use photosynthesis to convert solar energy into chemical energy. And they store energy in the form of carbohydrates, proteins, and oils, just like plants. So the plant oil can be converted to biodiesel, which is why biodiesel is in the form of solar energy. The more efficient a particular plant is at converting that solar energy into chemical energy, the better in the form of biodiesel perspective. And these algae are among the most photosynthetically efficient plants on Earth. Usually, these algae photosynthesis more 10 times faster than the plants. So, more oxygen is secreting by the algae more, um, than plants because these algae are photosynthesis 10 times more than plants does. So that this is also one of the reason why we can consider algae also as a source of fuel. We can also get the biofuel from this algae. For example, the annual productivity and oil content of algae is far greater than seed crops. For example, here soya bean can produce about 450 liters of oil per hectare. Canola can produce 1,200 liter per hectare, and palm can produce 6,000 liter per hectare. But algae, on the other hand, yields 90,000 liter per hectare. So these you can see the difference between other sources and with respect to the algae. So microalgae is also contain lipids and fatty acids as a membrane compounds. They storage products, metabolites, and sources of energy. So 22 to 40% of lipids or oil by weight can grow anywhere there is enough sunshine, and some can grow in saline water. So this doesn't require any field to grow. It's you can grow in anywhere under laboratory conditions or in the open pond system, in the fresh water, in the saline water, and the Yeah, you can generally you can grow anywhere. Enough when you have enough sunshine and carbon dioxide is sufficient for them to grow, definitely you can grow them. So all algae contain proteins, carbohydrates, lipids, and nucleic acids in varying proportions. So why Nannochloropsis? As I told, we have 30 more than 30,000 species, but not all the 30,000 species are what meant for this biofuel production or not for the industrial production. Though a few species, for example, Chlamydomonas, then Chlorella, um, then few other species also is responsible for biofuel production. But why Nannochloropsis? This Nannochloropsis, one of the genus that hold promising, uh, this one promising for the industrial production. Why? Because currently so many research is going on this, and they got to know that the high quantities of lipids, so which is present in this Nannochloropsis, are more, so other molecules used for energy storage, and so this is the best ideal. That is the reason, because of the high quantity of lipids, and they can storage more molecules, and they can rapid growth. Because of their rapid growth rate, it makes them ideal for the biofuel candidates. One particular species, especially among six species of Nannochloropsis, Nannochloropsis oceanica, is being studied as an example of algae's biofuel potential. Why Nannochloropsis oceanica? Because when compared to the uh, other for example yeast, when compared into the capability of yeast, you know that yeast microbes consume sugars in plants and convert them into ethanol, which can then be used as a fuel. So we can, when compared to the yeast, we can, these organisms were capable of photosynthesis, and just like same toolbox as yeast. So we can change, we could kind of sequence its genome, and determine into new genomes can be easily introduced into it. And it has only 1,200 genes, and less genome, less genes, you could sequence its genome very easily, and you can determine with the new genes, you can introduced into it, and you can just like made like yeast by after sequencing. That is how you can engineer this similar ways as yeast. That is the reason Nannochloropsis oceatica is an access to biofuel potential. So it's as I told, it's an identical candidate for genetic analysis. As I told, 12,000 genes. It is a compact genome and smaller than other algae. So as a smaller genome, you could play with it. You could genetic analysis would be easier, and sequencing could be much easier, and you can genetic engineer them as you want it, as you desired with any other organism. So that is the reason why Nannochloropsis oceanitica with is ideal candidate for this biofuel production. Another important point is it also contains enough unsaturated fatty acids like linolenic acid and polyunsaturated acid for the quality biodiesel. So these are the main reasons why, other than rest of the algal species, why we have to choose Nannochloropsis. So let us have a look on advantages and disadvantages of this biodiesel from algae oil. What could be the advantages and disadvantages? Definitely, it provides a rapid growth rates compared to the other plants as well, and grow particularly anywhere in high pre-acre yield. And it is non biofuel algae biofuel is non-toxic and highly biodegradable, and it reduces the carbon dioxide emission based on where it grow, and it produce high volumes. The biomass can be produced high volumes, and it biomass can be yield higher percentage of oil than the other sources. You can, as yeah, I have already given a picture of when compared to the other plant sources, this was like 90,000 liter per hectare you can expect from this algae. So you can expect higher percentage of biomass yield from this oil than other sources. So it's an and limited market competition. Still research is on and not so boomed up yet, so there will be a limited market competition here. And it can be cultivated on land, fresh water, sea water, anywhere. And the production is allow it to become more productive while consuming resources that would be otherwise be considered waste. So it's so productive. Algae, from the algae, you can use it as a resources, and it will be so productive, and you can not, otherwise you couldn't consider any waste here. So have a higher photon conversion efficiency, and you can harvest batch wise. You no need to be harvest at a one time. You can harvest batch wise nearly all year around. You can harvest batch wise, like a few species will be harvested after 1.5 months. So batch wise you can harvest it. So it can be provide reliable and continuous supply of oil, and can utilize salt and waste water streams, thereby greatly reducing freshwater use. Definitely. So as I spoke of only advantages from these algae, biofuel from algae, there could be, I would like to talk more on this disadvantages also. That is the reason, though it might look only three disadvantages in the list, but it is very complicating, and all the research is going on this disadvantages. uh, so definitely, so we should talk about disadvantages, otherwise we cannot go beyond limitation on this work, or to come out of this problem. And I would say, whenever we talk about disadvantages, definitely when we had a discussion, we'll come up with the new solution. So disadvantages are, these produces unstable biodiesel with many polyunsaturated. So as I told, algae has more polyunsaturates. It makes a biodiesel unstable. That is the one disadvantages. And biodiesel performed poorly compared to its mainstream alternative. So the performance would be very poor compared to other alternative, and it is relatively new technology. So that is the reason, for example, for cultivation cost more, harvesting cost much. So new research, new technique, we need to reduce the cost of cultivation, cost of harvesting techniques. So then I think we could go further. I think we could work beyond the limit to come over of these disadvantages from this algae. But still, research is on, and no one has stopped working on this. But and also, mm, uh, by being said that, so I would say algae is definitely a good source for the biofuel and biodiesel. So what are the challenges? Definitely, for any field or any plant source you take for the biodiesel, there could be challenges. It won't be easy. And what could be the challenges? Too much direct sunlight. When you use open pond system, definitely too much direct sunlight would be there. You cannot avoid it. That can kill the algae. And temperature must be constant. So overcrowding will be inhibit the growth algae. So too much of biomass will be inhibit the growth algae. So that should be taken care. And whatever the oxygen which has been produced from the algae, which considered as a waste oxygen, and must be continuously removed from the water. And open algal ponds are subjected to evaporation and rainfall, so you should take care of that. And that causes salinity and pH imbalance, which leads to the growth, which disturbs the algal growth. And the local species of algae often overgrow in desired strains. So all these are the challenges you need to maintain. So when these challenges will come up to you, only when you are cultivating. So that is the reason I told, when you go for cheaper and lesser cost of cultivation, then you will have these many challenges. But definitely you need and more investment if you want to avoid this contamination, and that will take much time to invest more on this, and that is the reason new technologies has to come up with these problems to overcome. So these are the challenges, and definitely the difficulties in efficient biodiesel production from algae are not from the extraction of algae, but in finding an algal strain with high lipid content. Definitely, so it is the deciding which species we have to go for a best for the production for the biofuel or algal fuel. So that is a big deal, because then only you can what to think of, you can plan for which cost effective cultivation system you can opt for, and what could be the harvest techniques will be costing, and it should not be too difficult to harvest and should not fast growth rate. And as I told, many polyunsaturated lipids will leads biodiesel unstable. So all these problems will arise. So one thing is choosing the right strain, algal strain is a one thing. Another thing is, after that, what the cultivation techniques will go through, what the harvesting techniques, and what the environment you are giving for the algae to grow, all that matters. So new materials and designs for cultivation in closed bioreactors and use for cutting edge metabolic engineering, screening, selection techniques are thought provide a biggest promises. But again, by saying this, um, it costs again new designs, new materials, new closed bioreacts. When it is terms comes to closed bioreaction, definitely it is a cost effective cultivation system, I would say. And but when you want to get a good what results without any contamination and not with so much of stress, then you have to go for these techniques, you have to select these techniques to provide, and definitely these techniques will be the biggest promises in the future. So I would like to conclude my remarks and future perspectives on this. So biodiesel derived from oil crops is a potential renewable and carbon neutral alternative to petroleum fuels. However, the high cost and the limited supply of renewable oils prevent it from becoming a top competitor for petroleum fuel. So, as petroleum fuels costs rise and supplies decreases, biofuel will become more attractive to both investors and consumers. So, because biodiesel from oil crops, waste cooking oil, and animal fat cannot fulfill a small fraction of existing demand for transport fuel, microalgae appears to be the only source of renewable biodiesel that is capable of meeting the global demand for transport fuels. According to the US Department of Energy, current research into efficient algal oil production is being done in the private sector, but if predictions from small scale production experiments show promise, then using algae to produce biodiesel may be the only viable method by which to produce enough automotive fuel to replace current world gasoline usage. So currently, large group of early stage companies working on algae who want to produce algae oils for biodiesel production, replacing a significant proportion of the diesel fuel that currently serves about one third of transport needs in the United States. Some commercial interest into large scale algal cultivation systems are looking to tie into existing infrastructures such as coal fired power plants or sewage treatment facilities. So, this approach provides an raw materials for the system, such as carbon dioxide and nutrients, and also changes those waste into resources. Thank you for your patience to listening to my presentation. These are the references, and thank you. You can contact me on this email ID if you're interested to contact. Any questions? So I'm glad to answer to them. Hello.